Dr. Shazrina binti Muhammad Fahmi. My ID number is 2023660934.
My name is Najwa binti Kamshani. My student ID is 2023809622.
Hi, my name is Rona Fisa binti Yuzaini and my student ID is 2023663902.
Hi, my name is Fatin Shamir Zawawi. My student ID is 2023663812.
What is differentiation? Differentiation is a method of finding of derivative or rate of change of a function. The rate of change of function is defined as dy over dx equal to fx equal to y.
So now, let's move to application of differentiation. There is 5 applications of differentiation. First one is related rates, analysis of function 1, analysis of function 2, maximum and minimum problems, and the last one is Rolle's theorem and mean value theorem.
Related rates. Related rates are rates of changing associated with two or more related that are changing over time. Our problem statement. On 3 June 2024, Air Selangor issued a notice of supply interruption of water in Klang area for 1 day. Therefore, residents are reminded to pour water for daily use before the interruption. Meaning, residents of Klang have a tank water that have cylinder shape. The water tank has radius RCM and height HCM to be made to hold 50,000 cm3 of water.
The objective of this topic is to show that the surface area of water tank. Second, to find the value of R and H that minimize the total surface area of water tank. The third one is hence find the minimum surface area of water tank.
So, how to solve maximum and minimum problems? There are 3 steps to solve maximum and minimum problems. The first step is we need to find the derivative of the equation. Second step, we need to let the derivative equal to 0 and find the values of the variables. For this question, the variables is R and H. R is radius and H is height. The last step is we need to do the second derivative test. If the second derivative test is larger than 0, so it's a minimum value. While if the second derivative test is lesser than 0, so it's a maximum value.
Question A. Show that the surface area of water tank is 2 pi r square plus 100,000 over r. So we know the area of cylinder is 2 pi r square plus 2 pi r h. And the volume of cylinder is 50/100. So we just substitute the volume of cylinder into the equation, which is pi r square h equal to 50,000. So we make the h as the subject for the equation. So we put it as h equal to 50,000 over pi r square. So area of cylinder equal to 2 pi r square plus 2 pi r h. We substitute the first that we make the equation, which is h equal to 50,000 over pi r square. So it becomes 2 pi r square plus 2 pi r in the bracket 50,000 over pi r square. So we just cut which one is the same one, which is pi r square. So it become equal to 2 pi r square plus 100,000 over r. So we got the equation. Question B. Find the value of r and h that minimize the total surface area of the water tank. So we know that area of cylinder that we got from the question A is 2 pi r square plus 100,000 over r. So we have to put r up, bring it up. So it become 2 pi r square plus 100,000 r power of -1. So step 1, we should find the derivative. So we put it as dA over dr equal to 2 multiplied by power of 2 become 4 pi r minus, because we multiply it by -1. So positive and negative become negative. So negative 100,000 r power of -2. Why -2? Because the power of negative 1 minus 1. So we got negative 2. So we can conclude that 4 pi r minus 100,000 over r power of 2. Step 2, we have to let the derivative equal to 0. So dA over dr is equal to 0. So it becomes 4 pi r minus 100,000 over r square equal to 0. So we have to find the r. So we bring the 100,000 over r square to the right. So it becomes 4 pi r equal to 100,000 over r square. So after that, we have to bring the r square to the left. So it becomes 4 pi r cube equal to 100,000. Okay, so we have to find the r, right? So we bring the 4 pi to the right. So it becomes r cube equal to 100,000 over 4 pi. Okay, so the r half cube. So we have to bring the cube to the right. So it becomes cube 100,000 over 4 pi. So we got the r, which is 19.96 cm. Okay, so step 3, we have to do the second derivative of the dA over dr. So we got 4 pi plus 200,000 over r cubed. Why 4 pi? Because the r1 we already did the second derivative. So the r we have to remove it. So it becomes 4 pi plus y plus, because negative 2 multiplied by negative 100,000, it becomes positive 200,000 over r cube. Y cube because negative 2 minus 1, so it becomes negative 3. So when we bring the power it down, so it becomes over r cube. So when r is 19.96, so we have to substitute the r into the equation that we already did the second derivative. So we get 37.72, but bigger than 0. So r equal to 19.96 cm is a minimum value. Why minimum value? Because it is bigger than 0. Question C. Find the minimum surface area of the water tank. So we can use the equation that we got from the question A, which is area cylinder equal to 2 pi r square plus 100,000 over r. So we can substitute the r. So we get 2 pi in the bracket 19.96 square plus 100,000 over 19.96. So we got 7,513.25 cm. That is the minimum surface area of the water tank.
So from the solution, we can determine the radius and the height of the water tank. The radius and height of the water tank was determined as 19.96 cm and 39.95 cm respectively. Moreover, the minimum surface area of the tank was calculated as 7513.25 cm square.